The streets of Paris hide secrets that, well, most people just walk past without a second glance. Granite columns rise from the sidewalks and building corners, these thick stone pillars that span multiple stories. Passers-by usually assume they're just structural elements or maybe old ventilation shafts, but the truth is far more fascinating. These are actually the last remnants of a compressed air network that powered the city's workshops, factories, and even clocks for over a century. This pneumatic grid once rivaled electricity in its reach and sophistication, and yet it has been almost entirely forgotten. Before we dive into this story, if you're passionate about uncovering lost technologies, forgotten history, and the hidden mechanics of past civilizations, make sure to like, share, comment, and subscribe to the channel so you won't miss any of these deep dives. The story begins in the 1850s in the Alps, where engineers faced a monumental challenge: tunneling through solid rock to connect France and Italy. Muscle and steam engines alone just couldn't drive the drills fast enough, so the engineers devised a new solution. Surface-driven water compressors forced air through iron pipes to pneumatic drills hundreds of meters underground. The results were astonishing. Drilling speeds increased sevenfold, and the tunnel was completed in record time. This success revealed a broader principle. Compressed air could transmit mechanical power efficiently over long distances, around corners, and into spaces where traditional shafts or early electrical systems simply could not reach. Victor Popp, a Hungarian-trained engineer who arrived in Paris in the late 1870s, recognized the potential to apply this principle to urban industry. Paris, at the time, was a city of scattered workshops, each small-scale manufacturer in need of mechanical power, but unable to install individual steam engines safely or efficiently. Steam engines carried fire risk, required constant attention, and operated poorly at small scale. Gas engines existed, but were temperamental, expensive, and equally hazardous. Popp's solution was elegant in its simplicity: build central compressor stations, distribute compressed air through underground mains, meter usage, and charge subscribers by volume. The system began operations in 1881 and quickly expanded. Compressor stations were strategically located near rivers for cooling water and coal transport. Massive compound steam engines drove air compressors capable of delivering dozens of cubic meters of air per minute at pressures up to 6 atmospheres. Cast iron mains ran beneath Parisian streets, following sewer lines and utility corridors, while vertical columns rose through building facades to workshops, complete with regulators and mechanical meters that accurately tracked consumption. Subscribers ranged from textile workshops to department stores, printing presses, and even public clocks, all relying on pneumatic power for smooth, controllable operation. The ingenuity of the system extended to the motors themselves. These weren't just simple piston engines, but sophisticated rotary vane motors capable of variable speed, instantaneous start and stop, and smooth torque. They could be mounted directly to machinery, eliminating the need for complex belt systems. For applications like printing presses or elevators, pneumatic motors were inherently safe. Leaks meant noise, not fire or explosion. The system even supported synchronized clocks across Paris, establishing a distributed time network that predated radio signals by decades, coordinating thousands of devices to within a second. This technology was not limited to Paris. Birmingham, England, powered hundreds of small jewellery and precision metal workshops. Buenos Aires, Dresden, Mexico City and Berlin implemented similar systems, adapting pressures and network designs to local climates and industrial needs. Each city demonstrated that compressed air distribution could be a practical urban utility, rivaling steam engines or early electricity in specific applications. Yet, despite technical success, the system eventually declined. Electricity advanced rapidly in the early 20th century, providing both lighting and mechanical power from a single source. Electric motors became safer, more reliable and cheaper. The unique advantages of compressed air, safety in flammable environments and variable speed control remained relevant, but they could not outweigh the efficiency, versatility and economic benefits of electricity. Subscriber numbers dwindled, and by the 1960s only a few specialized workshops continued using the system. The network officially shut down in 1994, leaving the columns, mains and valve housings embedded in Parisian architecture as silent witnesses to a forgotten century of ingenuity. The story of Paris's pneumatic network reveals more than a technological curiosity. It demonstrates how knowledge can vanish even when infrastructure persists. Within a single generation, engineers who operated, maintained, and understood the system retired or passed away. Technical literature survived in archives, but it ceased to be referenced in education or practice. Physical evidence remained visible, yet the interpretive framework, the understanding that these columns and pipes once powered a city, disappeared. Walking through Paris today, you can still identify these relics. Columns rising through building facades, capped pipes in basements, or fragments of valves and gauges are all there. They are a testament to ingenuity, to solutions tailored to the needs of their era, and to the fragility of collective technical memory. For history enthusiasts and urban explorers alike, these structures offer a tangible connection to the industrial past, waiting to be recognized, documented, and appreciated. If this deep dive into lost infrastructure has intrigued you, make sure to like the video, leave a comment, sharing what city's hidden history you'd like us to uncover next, and subscribe to the channel so you never miss another episode of Warcraft Survival. Sharing this knowledge helps preserve the memory of technologies that shaped our world and ensures that these stories continue to inspire curiosity and discovery.